Last week, we spent the week talking about rational expressions, how to simplify them, how to add, subtract, multiply, and divide them. Today, we're going to be talking about how to solve equations that involve rational expressions. So now that we know how to work with them, add, subtract, multiply, divide, we now are going to use them to solve equations. One thing I noticed as we were working last week on our rational expressions is some people had forgotten that 2x is actually 2 times x. That 2x is not its own unit, its own term. It can be broken up. And that is important because in this section we talk about lowest common denominator. We need to know that. But also with adding fractions, we need to know that there's a lot of times that we need to understand that, and people were forgetting that 2x is actually 2 times x. Now, I bring that up because our first example, we are going to be solving different equations. And in order to solve equations, in this case, they have adding and subtracting going on in them. So we need to remember that because we need a common denominator. And to find our lowest common denominator, we have to know what the factors are. And so this is like 2 times x and 5 times x and x squared. And so as we look for a common denominator, we're going to look for the lowest common denominator. And again, some people were kind of, to compare it back to elementary school, they were just finding any common denominator, maybe the biggest common denominator. We don't want the biggest common denominator. We want the least common denominator. And so when I break this up and I think about this, I don't want this to be, for instance, 10x to the third or 10x to the fourth. I really only need it to be 10x squared. And so in other words, the way I got that is I looked at this and had a 2 and an x. This had a 5 and an x, and this has an x and an x. And all I need is the lowest common denominator. So in other words, all I need is the 2, the 5, and the x and the x. I don't need these other two x's because they're already listed down here. And so my lowest common denominator in this case is 10x squared. Now that I know what the lowest common denominator is, now I'm ready to apply this method. And the method is to multiply the entire equation by the LCD to clear the fractions. In other words, if my lowest common denominator is 10x squared, then I'm going to multiply that on both sides. When I do that, I'm going to put it over 1 because some people forget how to multiply those unless it's over 1. And so putting it over 1 reminds us how to multiply these. Now on the left-hand side, I am going to need to distribute this. And what's going to happen, it is going to clear the fractions. In other words, we are just about to get rid of all of the fractions. I'm going to show my steps to get there. So if I distribute this, I'm going to have 10x squared over 2x minus 20x squared over 5x. And again, I put it over 1, so we remember that. And then on the right-hand side, I have 10x squared over 10x squared over x squared. Now, each of these fractions will reduce down to where they're not a fraction anymore. So let's just take a look. 2 goes into 10 5 times, and one of these x's cancels with one of these x's, and so this fraction is actually just 5. Over here, the 20 and the 5 goes into 24 times. One of these x's can cancel with one of these x's, and so we are left with a 4. Excuse me, back on the first term, I left that x. I forgot I had that x. I canceled out one of the x's because it was x times x, but one of them remains. So I do need that x, and the same thing over here. That x canceled, and one of those still remains, so I need my x over here. And on the right-hand side, my x squares cancel, and so I just get 10. So now I have a really easy equation to solve. 5x minus 4x is just 1x, so x equals 10. Now, one thing I do need to check for is I need to see, is it extraneous? And do you remember what that word means? Extraneous means if you plugged it back in, would it work? So if I plug this 10 back in, I'm going to get 1 over 10 minus 1 over 20 minus 2 over 50 equals 1 over 100. But extraneous is a little bit more specific than that. It basically is telling me, is it defined? So if I put the 10 down there, I get a denominator of 20, I get a denominator of 50, and I get a denominator of 100. And all of those are okay. So it is not extraneous. But I wanted to bring up that concept just so that you would remember that's something we have to pay attention to. The next example is similar. It's just, for us, it's actually a little bit more advanced, but also for us, for some of you, as I saw you working last week, it might be a little easier to understand in a way. All right, as we look at example number 2, we need to look at this and think about what is our LCD. So on number 1, we came over to the left and we found that. On number 2, let's still again think about that. Our LCD here, we have an x and an x plus 1. Our LCD is just x times x plus 1. Now, remember, you cannot just say like a plus 1 over here and a plus 1 over here. That is not how fractions work. And I think if you thought about a number, it would make sense. Like let's say this was 4/3. If that was 4/3 and I added 1 to it, I would get 5 over 4. Does 5/4 equal 4/3? No, it doesn't. So you can't just add like that. You have to go through and use the LCD. So for our LCD, we determined it was x times x plus 1 because those are the factors that are involved. And so when I multiply this, I'm going to multiply both sides by x times x plus 1 over 1. And the reason I can do it over 1 is because I'm doing it to both sides. So sometimes we do it over itself, but this time we're doing it to both sides. So anything you do to one side, you have to do the other side. And so that's why it's okay to do that. All right, now that I've done it, I'm going to go ahead and multiply this and by distributing. And again, I'm going to show all my steps, even though a lot of you are able to skip some steps, and I don't mind you skipping steps. When I'm teaching it, I'm just going to show you all of the steps. So I'm going to multiply that, it's 4x times x plus 1. I'm going to multiply this, that's 3x times x plus 1. Now these will cancel in just a minute, but I'm writing them out as they are right now so that I have them, and so I can show you all the steps. Okay, now that I've done my distribution and multiplied all of them, I'm going to cancel anything I can cancel. So for instance, this x and this x can cancel. This x plus 1 cancels with this x plus 1, and that's just a 1, so we don't really need that because we're getting rid of the fractions. That's what we wanted to do, is get rid of those fractions. So now I have 4 times x plus 1. I need to distribute that, and that is 4x plus 4. Minus, everything canceled out, all I have left over is a 3x. And then I have my equal sign, and I have x squared plus x because I need to distribute that. Now, since it is a quadratic, I need to get it all onto one side and get it equal to 0. I'm going to simplify this side first. You could do it in any order, but I'm going to simplify this side first. So that's going to give me x plus 4 on the left and x squared plus x on the right, And now that I've simplified that, I'm going to get this equal to 0. So I'm going to subtract my x from both sides, and I'm going to subtract my 4 from both sides. And so what I have is I have a 0 on the left, and x squared, those two, x minus x is 0, drops off, and I have a minus 4. Now I need to solve this quadratic any way I want to. I can solve it by quadratic formula, I can solve it by factoring, I can even solve it by just taking the square roots. But I'm going to solve it by factoring because I think a lot of us are familiar with that. So that's x plus 2, x minus 2, and then we can solve that and we get our solutions are positive and negative 2. Once again, we need to ask ourselves, are these extraneous? And again, extraneous means if you plugged it into the denominator, would it make it a undefined problem. And if I take those 2's and negative 2's, those are fine. They work. I don't need to worry about extraneous in this situation. Okay, take a minute now, pause the video, and see what you can do with example number 3. Okay, let me show you what I did here on number 3. First of all, I looked at the problem and I determined my lowest common denominator. In this case, lowest common denominator was 3x squared. So I multiplied both sides times 3x squared over 1. I go and distribute that. And when I distribute it, I got 33x squared over 3x minus 3x squared over 3 minus equals negative 12x squared over x squared. Those reduce and simplify down to 11x minus x squared equals negative 12. I set that equal to 0, so I move those two over to the right. I set it equal to 0, and I have to factor this. It is a quadratic. The way I solve a quadratic typically is by factoring. So I solve it by factoring. I factor it. I get my two solutions of a positive 12 and a negative 1. I do need to check for extraneous and look and see if those are any extraneous solutions. So 12, that's okay. Negative 1, that's okay also. However, I hope you can see I'm checking every single time. So one of these times it's going to turn out to be extraneous. Okay, so that was one method. The first method, what we just did, we multiplied the whole thing by the LCD. That got rid of the fractions. The second method is still looking at the denominators, but it's to create the same denominator and then set the numerators equal to each other. And in order to do that, we're going to need to factor this. So I'm going to take a second to factor this. Now I have the denominators factored, and so now I'm able to see what my factorization is, so I can then create the same denominator. Because let me say I'm just going to make it really simple, like 3 over x is equal to n over x. Now I know that I'm mixing a bunch of variables here, but that's okay. Don't you know that n has to be 3? Maybe another example. You don't need to write these down, but let me show you another example. Let's say I had 1 plus n over x squared, and I had that equal to 5 over x squared. Well, if they're both over x squared and they're both equal to each other, doesn't n have to be 4? In other words, the x squares don't really matter. All I really need to look at is that numerator. And so n's going to be equal to 4, no matter what that denominator was. All right, that is the basic concept of the method that we're going to use in this section. And to me, this is one that makes a lot of sense. But I'm giving you multiple options here, so you can choose which one works for you. You don't have to use all of them. You pick the one that works for you. Okay, so I see 3x plus 1, and I see an x plus 1, x minus 1. In other words, this one needs an x minus 1 in order to have the same denominator. Kind of like when we're adding. We have to have a common denominator when we add. And if I multiply it by the bottom, I have to multiply it by the top. On the right-hand side, I could see that there was a 3 missing, so if I multiply it on the bottom, I have to multiply it on the top. Now, I have the same denominator all the way across. Now, I don't really need that denominator anymore. If it's the same thing, it doesn't really matter. And so I can basically just cross all that out. Another way to think of it is you can now multiply by the same common denominator on both sides, and it would cancel out the denominator. In any case, what I'm going to have on the left-hand side is I have 4 times x minus 1, and on the right-hand side I have 12 times 3. Or in other words, 4x minus 4 is equal to 36. And now I can just go ahead and multiply this out, and I can just solve this for x. So I'm going to get 4x, add my 4 to the other side, and I get 40, and so x is equal to 10. And as always, I want to see is it extraneous. I go up here, looks like 10 is okay, so that does work. why don't you pause the video here? Maybe it's too early. If it's too early, just click on through. But maybe you're able to solve this one on your own. See what you can do on example 5. When you come back, I'll explain it. Okay, let me show you what I did on number 5. My common denominator was going to be a 4x. So I had to multiply this one by x and x, this one by 4 and 4, this one by x and x. Then I multiply those out, and I get 5x squared over 4x minus 12 over 4x is equal to x over 4x. In other words, I now have the same denominator. I can cross those out. I do not need those anymore. However, what I have up here is a quadratic, so I'm going to set it equal to 0. So I'm going to subtract that x over here, and so I have 5x squared minus x minus 12 is equal to 0. Okay, I need to check this by the AC method and see, can I factor it? Or maybe I just don't like factoring at all. But anyway, I check by AC method and I get negative 60, and I try to think of what will go in there that will make it be a negative 1. And I can't find anything, and nothing works. And so since nothing works in the AC method, then I have to go to the quadratic formula. So I go into the quadratic formula and I get my two solutions, positive 1.652 and negative 1.452. So just remember, if you can't factor it, you do have to do the quadratic formula. Let's turn the page. On the next section, this method I'm going to use is cross multiplying. I'm reluctant to use cross multiplying because people get it confused. People do weird things. However, I feel like it's important because once you understand it, you end up using it a lot. And if you know how to use it, you'll use it a lot in chemistry and a lot of other things. So I feel like it's important for us to take a look at. By cross multiplying, what we do, and maybe another way, in fact, there's another way that I could teach this, but I'm just going to stick with cross multiplying for here. What we do is we're going to multiply 5 times x minus 1. X squared minus 1. And then so I went this way and I multiplied those. I'm going to go this way and multiply these. And it does not matter which side, left or right, which one goes on the left, which one goes on the right. And now, of course, I need to distribute these and then I will solve them. But that's cross multiplying, is just to go make an x like that with your multiplication. And like I said, I'm reluctant because a lot of people just start going cross diagonal with a lot of weird things they're not supposed to. This method, another thing, this only works if there's only one fraction on each side. If you look down at number 8, do you see how there's 2 fractions over here? You could not cross multiply. There's no way to do that. But you can. Anytime there's just a fraction equal to a fraction, that's when you can cross multiply. Okay, so now if I set this equal to 0, I'm going to subtract my 30x from both sides, and I'm going to add 30 to both sides. And now I need to do something about this. I need to factor it. And I can see, first of all, there is a GCF, so I'm going to factor out that GCF. Now that I've factored out the GCF, it's just a matter of guess and check, basically. If there's no a term in front of the x squared, these are pretty easy to factor, and hopefully you by now are getting good at this. So when I do this, remember that 5 doesn't do anything to the problem. What it does to the graph is it stretches it vertically and makes it longer, but it does not change our x-intercepts. For our x-intercepts, or our solutions, because x-intercepts are the solutions, we just have to set each of those equal to 0 and solve it, and we get our 2 solutions of x equals 5 and x equals 1. We need to see if any of our solutions are extraneous. Well, can you see already the x equals 1? That's not going to work. It's going to give me a 0 in the denominator. So that one does not work. It is extraneous. However, x equals 5 is a valid solution. So that one does work. Just make sure you always check to see, because you never know when that's going to pop up. So you just have to check it every single time. And all it does is take a second out of your time to go back and look in the original problem. And in the original problem, it's going to make a 0 in the denominator, then it is extraneous. So I plugged in a 1, it made a 0, that makes that extraneous. Example 7 is really similar. Why don't you take a second, cross multiply, see what you get, and see if you have any extraneous solutions and if you have any valid solutions. Okay, to cross multiply, I go across one way and I go across the other way. I need to distribute these, so we get negative 4x minus 8 is equal to 15x plus 30. I need to solve this, so I need to gather all my x's on one side and all my non-x's on the other. If it was a quadratic, I would need to set one side equal to 0, but this is not a quadratic, it's a linear, and so there's no x squared term, and so I just need to get my x's on one side and my non-x's on the other. So I do that, and I come up with 19x is equal to negative 38. I need to divide by divide by positive 19, and I get a negative 2 as my solution. And if you go back up and plug in a negative 2, that makes our denominator 0. So that is not a possibility. And so it is a no solution answer because we only had one pop up and it doesn't work. So this is no solution. And maybe if you were paying attention, you might have been able to see that at the beginning. Because look at what we have. I'm going to erase this for a second. Look at what we have. We have an x plus 2 and a 5 times x plus 2. And we have a negative 4 and we have a positive 3. There's no way that that's going to work. You can't have a 5 times over here unless this was 15, and it's not 15. So that's not going to work. Okay, the last method on this page, it is convoluted. I'm not even sure really why it belongs in here. I don't like it for a couple of reasons, but it is a method and you might stumble across using it, like accidentally you might use it, and it does work. The idea is that you would create a proportion and you would cross multiply. In other words, these top two examples we were able to cross multiply because it was just a fraction equals a fraction. If we really loved cross multiplying, we could redo our problem to make it to work for cross multiplying. In other words, if I subtracted 1/8 from this side and subtracted 1/8 from this side, then on the left hand side I would have 5x over x plus 2. On the right hand side, I need to figure this out. I need a common denominator. So 5 halves, if I multiply that by 4, is going to be 20 over 8. So I have 5x over x plus 2 is equal to 19 over 8. Okay, I told you it's a little bit convoluted. The only reason you would really want to do this if you just love cross multiplying, and it's the only thing you know how to do, then here you go. So now that I have a single fraction equal to a single fraction, which is called a proportion. That's what this is. It's a proportion. But now that I have that, I can multiply this way. That gives me a 40x. And multiply this way. It gives me a 19x plus 38. And now I could solve it. Subtract my 19x from both sides. I get a 21x. Divide by 21. And I get 38 over 21. Why would you ever want to do that? I don't know. You just sometimes, I mean, you guys know, you just get in the middle of a problem, you get stuck, you don't really know what to do. So this works. You can do it. Is it an extraneous solution? It's not extraneous. It's fine. It works. Take a minute to write some things down in the summary. Just remembering you don't have to know all of these, but you need to know at least a couple so that you know which ones work, you know how to use them, and sometimes some of them are more convenient than others, so it's helpful to have more than one tool in your toolbox. So go ahead and write down some summary, and again, we'll do some examples tomorrow in class.